Good morning, Laboratory High School. This is your math teacher, Sir Bryan Cunanan. And because you are under science and technology curriculum, I know all of you are advanced in mathematical abilities like we are going to discuss for this session. So, our discussion for today is all about divisibility rule from 2 to 13. So let's start by giving the definition of divisibility rule. Divisibility tests or division rules in maths. As the name suggests, divisibility tests or division rules in math help one to check whether a number is divisible by another without actual method of division. If a number is completely divisible by another number, then the quotient will be a whole number and the remainder will be 0. And that's divisibility. So, to start our discussion, let's start with that. Divisibility rule of 2 says here that if a number is an even or a number whose last digit is even number like 2, 4, 6, 8 including 0, it's always divisible by 2. For example, it's 508 divisible by 2. To check whether 508 is divisible by 2, we need to take a look at the last digit, wherein the last digit is 8, and 8 is an even number. Therefore, the original number wherein 508 is divisible by 2. And that's the divisibility rule of 2. Let's proceed to divisibility rule of 3. So, states that a number is completely divisible by 3 or not if the sum of its digit is divisible by 3. For example, it's 309 divisible by 3. To check whether 309 is divisible by 3, we need to get the sum of 309. We need to add 3 plus 0 plus 9 equals 12. And we know 12 is a multiple of 3. Therefore, the original number 309 is also divisible by 3. And that's the divisibility rule of 3. So let's proceed to divisibility rule of 4. If the last two digits are divisible by 4, therefore, the original number is also divisible by 4. For example, it's 2,316 divisible by 4. To check whether 2,316 is divisible by 4, we need to take a look at the last two digits, and that is 16. So we know that 16 is a multiple of 4. Therefore, the original number 2,316 is also divisible by 4. And that's the divisibility rule of 4. Let's proceed to divisibility rule of 5. Number whose last digit is 0 or 5 are always divisible by 5. Like 10, 5, 20, 100, 1,000, 5,000, 1,000,000, and 5, and so on are always divisible by 5. Divisibility rule of 6. Number which are divisible by both 2 and 3 are divisible by 6. That is, if the last digit of the given number is even and the sum of its digit is a multiple of 3, then the given number is also divisible or multiple by 6. For example, it's 660 divisible by 6. To check whether 660 is divisible by 6, we need to take a look at the last digit, which is 0, because 0 is always divisible to all the numbers. Therefore, 660 pass the divisibility rule for 2. So next, we need to get the sum of all the digits in 660. So we need to add 6 plus 6 plus 0 equals 12, and 12 is a multiple of 3. Therefore, the original number 660 is divisible by 6. And that's the divisibility rule of 6. Divisibility rule of 7. The rule for divisibility by 7 is a bit complicated, which can be understood by following the step that I will give. So the first step we need to do is to remove the last digit of the given number and double it. After that, we need to subtract from remaining numbers. And after that, we need to repeat the process until the number become a single number or a single digit. If the number is a multiple of 7, then the whole or the original number is also divisible by 7. For example, it's 1071 divisible by 7. To know if 1071 is divisible by 7, we need to follow the given instruction. We need to remove the last digit, which is 1, and double it, and it will become 2. So 107 minus 2 is equal to 5. Then repeat the process, remove the 5 and double it, then subtract to the remaining number. So it will become 10 minus 10 equals 0. Because 0 is divisible by all numbers, therefore 107 is also divisible by 7. And that's the divisibility rule of 7. Divisibility rule of 8. If the last 3 digits of a number are divisible by 8, then the number is completely divisible by 8. For example, it's 24,040 is divisible by 8. To check whether 24,040 is divisible by 8, we need to take a look at the last 3 digits, then divide it into 8. So, in 24,040, we need to get 040, then divide it into 8, which is 5. Because the last 3 digits is 040 and it's divisible by 8, therefore, the original number 24,040 is also divisible by 8. And that's the divisibility rule of 8. Let's proceed to divisibility rule of 9. The rule for divisibility by 9 is similar to divisibility rule for 3. This is, if the sum of its digit of a number is divisible by 9, then the number itself is divisible by 9. For example, it's 78,525 divisible by 9. To check whether 78,525 is divisible by 9, we need to get the sum of all the digits like this. 7 plus 8 plus 5 plus 2 plus 5 is equals 27. And 27 is a multiple of 9. Therefore, the original number 78,525 are also divisible by 9. And that's the divisibility rule of 9. So let's proceed to divisibility rule of 10. State that any number whose last digit is 0, it's always divisible by 10. Like 10, 20, 30, 1,000, 5,000, 60,000, and 1 million. They are all divisible by 10. And that's the divisibility rule of 10. Divisibility rule of 11. In divisibility rule of 11, we have two ways in finding if the given number is divisible by 11. The first is if the number of digits of a number is an odd number, then subtract the first and last digit from the rest of the number. For example, it's 82,907 divisible by 11. The number of digit is 5, so it's an odd number. So we need to subtract the first and last digit to the rest of the number, or to the remaining numbers. So now we have 290 minus 8 minus 7 is equal to 275. And 275 is a multiple of 11. Therefore, 82,907 is divisible by 11. And the second way in finding the divisibility rule for 11 is this. It's about if the digits of the number is an even number, we need to add the first digit and subtract the last digit from the rest of the number. So, if, for example, it's 3,784 divisible by 11. So of a number of digit is 4 and it's an even number. Now we need to follow the instruction. So 78 plus 3 minus 4 equals 77. And 77 is a multiple of 11. Therefore, the original number 3784 is also divisible by 11. And that's the two ways in finding the divisibility or in solving the divisibility rule of 11. Divisibility rule for 12. If the number is divisible by both 3 and 4, then the number is also divisible by 12 exactly. So for example, 8,225,124 is divisible by 12. To check whether 8,225,124 is divisible by 12, we need to pass the two divisibility rule, which is 3 and 4. First, we need to get the sum of all the digits. We have 8 plus 2 plus 2 plus 5 plus 1 plus 2 plus 4 is equal to 24. And 24 is divisible by 3. Therefore, 8,225,124 has the divisibility rule for 3. So second, we need to take a look at the last two digits. So the last two digits here is 24. And 24 is also divisible by 4. Therefore, the original number 8,225,124 is also divisible by 12. And that's the divisibility rule of 12. For the last divisibility rule for today's discussion, it is divisibility rule of 13. For any given number to check if it is divisible by 13, we have to add 4 times of the last digit of the number to the remaining number and repeat the process until you get 2-digit number. And we need to divide it into 13 to check if it's divisible by 13. And if it's divisible by 13, then the given number is also divisible by 13. For example, it's 2,795 is divisible by 13. So we need to follow the instruction. So 2,795 and the last digit of it is 5. So we need to multiply it into 4. So and add it into 279. So 279 plus 20 is 299. And we need to repeat the process. So 9 times 4 is equals to 36. We need to add to 29. 29 plus 36 is equals to 65. And the number 65 is divisible by 13. 13 times 5 is equals to 65. Therefore, 2,795 is also divisible by 13. And that's divisibility rule from 2 to 13. Thank you for watching. I hope you learned.